Hi, my name is Brian and welcome to another video on continuity. In this video, we're going to take a look at where this function f of x is continuous or not continuous. Okay, this function is made up of three pieces, so it is a piecewise function. Let's take a look at the obvious parts first. We have a jump point at 1, meaning that we are going to jump from one function, the x squared plus 1, to the other function. And we have this possibility for a jump discontinuity, where one function and the other function don't meet, and you'd have to jump from one to the other. We're also going to have that possibility at x equals 4. So let's start with 1. See if you're continuous at 1. Now the three conditions of continuity are that f of a must exist. We need to have the limit as x approaches 1 of f of x exist, and that limit that exists and f of 1 must also match, so they have to be the same as well. So those are the three conditions. So let's start with the first condition. So let's say at x equals 1. Well, does f of 1 exist? You are allowed to equal 1 here, and so when x equals 1, I'm allowed to use this function, and so that's going to be 1 squared plus 1, which is 2. So f of 1 exists. What about the limit? Well, since 1 is a place where we're jumping from one function to another, the left and right-hand limits are going to use two different functions. So let's take a look at the left-hand limit. Now that's using the x squared plus 1, because if you're approaching 1 from the left, that means you're slightly less than 1. That's what that means. All right, and then I'm just going to plug in 1. Nothing bad happens, right? You're not dividing by 0 or anything. And you get 2. Let's take a look at the right-hand limit. So x is going to approach 1 from the right. Now that is going to use the 3 minus x. Again, you're slightly bigger than 1. That would put you in this interval. So I'm going to use 3 minus x. And when I plug that in, I'm going to get 3 minus 1, which is 2. And what you see is that the right-hand limit and the left-hand limit match, and so that means the general limit matches as well. So this was condition 2. This was condition 1. Both are satisfied. Let's move on to condition 3. Does the function value and the limit match? And they do. So let's write that down somewhere. So since the limit as x approaches 1 equals f of 1, which again is 2, then we are continuous. Is continuous at 1. All right, so let's focus on 4. Okay. Line here. Actually, we can go right here. All right, so at x equals 4. So let's take a look at condition 1. Does f of 4 exist? Well, I'm allowed to equal 4 right here, so I'm using the 3 minus x as my function. When I evaluate that, I'm going to get 3 minus 4, which is negative 1. All right, let's take a look at condition 2. Sorry, I am off screen, but that's okay. All right, we're going to do the left-hand limit. Now it means I'm slightly less than 4, and that puts me in this interval here. So I'm going to use 3 minus x. And then when I plug in 4, I do get negative 1 again. So let's take a look at the right-hand limit. Now that means I'm slightly greater than 4, and that uses the squared function. So square root of 4. Now since the left-hand and right-hand limits don't match, we get to say that the limit as x approaches 4 does not exist, which we use the DNE. So since this doesn't exist, f is not continuous at 4. So we had a good point at 1, bad point at 4. How do we write out our final answer? Well, real quick, each one of these functions are continuous on their domain. So x squared plus 1 is continuous when x is less than 1. Can't count 1 yet. I mean, we can now. but we couldn't count it before because it was a jump point. So as of right now, we get to say that we're continuous from negative infinity all the way to 1. So let me write that down here. Negative infinity all the way to 1. Now since I just said we are continuous at 1, we can keep going all the way to 4. And we said we're not continuous at 4. That means we have to skip over 4, give it a parentheses, and then we can continue from 4 to infinity. So right here is our final answer. So you can say that you're continuous on those intervals or that you are discontinuous at 4. Now just because we can, I'm actually going to put the graph of this piecewise function up right over there. And you can actually see that the x squared plus 1 and the 3 minus x meet at 1, so that made that continuous. However, you can see the jump point where we're jumping from 3 minus x to square root of x at x equals 4. So that confirms what we found here. Anyways, hope this helps. Good luck. Bye.